Hello. Get a couple more things set and we'll get started here. There we go. Okay, I think I got everything set right finally here. So a couple details that you see on the board here. We have our quiz. Now I don't have this by points. This is by average because that's the way Canvas reported it. A couple other comments about grading. I do not have everything caught up. Your take-home exams are going to take me a little bit. So unless you have objections, your take-home exam, you're just going to see a score. If you want to see more than the score, I will have it for you at the end of finals week. But I'm hoping to be able to have your take-home exam scores up by the end of the day, Wednesday or so you'll have a chance to take a look at those. A couple other details about this week, okay? So we are done with everything except for the final exam in this class, although there are a number of things that are not turned in from different people. I will tell you right now, so even though the official thing in the syllabus says late work will not be accepted, I will accept late work for less than full credit. However, it'll be enough to make a difference for a lot of you. So if there's something that's not in, go ahead and get it turned in. If you have questions about it, I am going to have office hours today from 11 to 11:45, and I'm going to do from 1:45 to 3:50. Sorry, 1:45 to 2:15. Sorry, not 3:15. 1:45 to 2:15. I don't have that one yet, but it should be the same link. Now, I don't know. I'm supposed to have all the classes password protected, but I think if you just go with a link that I gave you, you should be able to get in. If not, hopefully you have found the password that was in the email. I don't think it's a very hard password to remember, so go with that. All right, couple other things. The final exam will be Monday. Now, on this exam on Friday, evidently I messed up with one of the settings there, and I figured out what setting that was, and I will have it corrected for Monday. As it is, I know there are going to be a couple issues. The final exam has to be given on a lockdown browser in order for me to have the rights for the ACS. So that is how it's going to be. If you cannot use the lockdown browser, I want you to try to find an alternative way of taking the final. I know if you only have a Chromebook, you need to contact me on that. Hopefully there'll be some other option for you for the final. If not, we'll figure something out. Okay, so that's one of the big things. The final exam, you will need a 2-hour time period for it, okay? So there'll be a couple minutes at the beginning where you'll need to be getting a couple details in. but for the most part, everything should be good. All right, and let me see, this is a, all right. So we have finished nuclear chemistry. We have finished electrochemistry. We have done equilibrium. We have done kinetics. We have done colligative properties. And that is pretty much everything that is really important for us to cover in general chemistry too. There's one more thing I want to do, and that is especially for those who are not going to be taking organic chemistry. We need to take a look at how a lot of this relates to biology. And in order to do that, we need to start with some organic chemistry. So I am going to give you a brief introduction to organic chemistry and a little bit of its naming. And with that, I'm going to erase this. Now, this, I'm going to make sure here, this is recording. And because it's recording, I'm not going to feel bad about going fast. Okay. And I need a couple other markers handy. So, organic chemistry is all about the element carbon. See? Okay. I know you're thinking, wow, that's pretty deep, right? Carbon, if we remember, has 4 electrons in its outer shell. So if we got our dot structure, it shows 4 dots there, which would indicate carbon is willing to share 4 electrons. So carbon is very stable. It can form 4 bonds. It also has the ability, now remember our Lewis structures. Those represent bonds. Now I'm going to do something today that normally I would do part way through, but since I have a smaller board, I'm going to do this now. Now, if I draw this, this is the same as that. These two are equal to each other. If I don't put anything on the end of a bond, it's understood that that's a hydrogen, okay? So this would be CH4. And it is going to be named based on a couple things. The first thing it's going to be based on is the number of carbons that are present. And we are going to have a system with the longest chain of carbons. Now, carbon has the ability to form really long chains. Hundreds of millions of carbons can be connected in a row. That is called catenation. Now, it's not the only one that can form a lot of bonds, but it's the only one that really we see extremely stable with lots of bonds that are formed, okay? So when we start looking at an organic molecule, an organic, it contains carbon. What we're going to do is we're going to start by looking for the longest chain. And that longest chain is going to be named based on how many carbons there are. So 1 carbon is a meth, 2 is a eth, 3 is prop, bute is 4, pent is 5, X is 6, hept, oct, non, and dec. And yes, we can go a lot farther than that, but I'm not going to have you memorize all that or learn all that. I want you to be aware that these are the roots, and if you see one of these, it has to do with the number of carbons. And I know you're thinking, this has 1 carbon. Oh, hey, that would be a meth something or another, okay? And lots of people, when they hear the term meth, think of a particular drug that does start with meth. But if you were to look in the catalog of organic compounds and you looked at all of the compounds that start with meth, you would realize that it's in the millions. So that's not necessarily very particular for it. Now, in this particular case, we have something called a hydrocarbon. A hydrocarbon contains only carbon and hydrogen. Okay, and we're going to start with our organic chemistry by just looking at carbon and hydrogen. Now, in this case, I have CH4. Okay, this is a carbon and hydrogen with only single bonds. This is called an alkane. And I know you're thinking an alkane, that's what you're going to be walking around with when you're old and decrepit, right? Okay, so I will still keep telling jokes, even if you don't laugh at them. Okay. Methane. Okay, this is an alkane. Contains only carbon and hydrogen. We name an alkane by giving it the suffix ane and the root for the number of carbons. So a one carbon alkane is going to be methane. Okay. Now, you will need to refer to these quite a bit, but I don't have enough boardroom here. Normally, I would leave them on the board in some place. In your case, I'll just mention what they are every day. But you can always go back and look at that or find that. So this particular one is methane. Okay, so what happens if we have two carbons in a row? Okay, I have two carbons here. Okay, notice I have the full set of bonds around here. This is going to be C2H6, and it has two carbons, F, all single bonds, Fa. What if I have three carbons? Now, just because this is important, what if I have N carbons? If I have an alkane with N carbons, what am I going to have? Okay, so if I have N carbons, how many hydrogens am I going to have? Well, if I look at my simple set right here, CH4, C2H6, C3H8, if I have C to the N, H is going to have 2N plus 2 carbons. If I have N carbons and 2N plus 2 hydrogens, I have the maximum number of hydrogens that is possible. This is known as a saturated hydrocarbon, okay? And yes, you've heard of saturated and unsaturated fats. We'll talk about those just a touch on Wednesday, but this is where that term comes from. So if I have a maximum hydrogens, it's saturated, okay? And when we're talking about alkenes, we'll have to look at that. Now, let's remember something. Let's remember something from Gen Chem 1 here. If I look here, it looks like these carbons are all nice and in a line. But in reality, what is this bond? This is a 1, 2, 3, 4. I have 4 bonds on this. This is an sp3 hybrid orbitals. sp3 hybrid orbitals, if you will remember, have what type of a structure? Tetrahedral. That bond angle is not a 180-degree bond angle. It's also not a 90-degree bond angle. It is a 109.5-degree bond angle. So in reality, when I start drawing chains of hydrocarbons, I should try to draw them with about 109.5-degree bond angle. But since I'm drawing in 2 dimensions, that's going to be a little bit tougher. Now, sometimes we use a simple system like this, which are sometimes called daggers and dashes. This is coming out of the board. This is going into the board. Okay. But I'm not going to use this on a regular basis unless I'm really looking at the shape of something. But the shape is going to be important. Now, why that's important is when I draw this, I could draw it like this. Let's even make it more fun. If I draw it like this. Now, I'm going to make another adjustment here. All carbons have 4 bonds. A bond's not drawn, that's going to be to a hydrogen. This is another shorthand that we use, okay? Here I have 1, 2, 3, 4, 5 carbons here. 1, 2, 3, 4, 5, 6. This bond between carbon, carbon, and carbon is 109.5. This one here is 109.5. Our longest chain is not necessarily the one in the straight row that we have here. In this case, I have 1, 2, 3, 4, 5, 6. I have 6 carbons. 6 carbon root is called a hex, and it is hexane. However, this is also hexane. So this is not the same formula, okay? This is hexane, so this has something on here. We call it, for shorthand, I'm gonna call it a branch, but in reality, it's what's known as an alkyl group, okay? It has a single carbon on it. Now we use the same root for this. So in this case, I have a root for this, meth, but because it's a branch or an alkyl group, we call it methyl. So this is methylhexane. Now what's interesting is I can actually have different possibilities here. This is methylhexane and this is methylhexane. If I look at them, they're both C7H16. I have two different things. I could also have heptane, that would be C7H16. They're all different molecules. They're all different structures, even though they have the same formula. Things that have the same formula but different structures are called isomers. Isomers are really important. Now, there's a number of different types of isomers, but in this particular case, we are looking where the atoms are put together in a different format. Okay, they're not put together the same. Okay, these are isomers. Okay, so how are we going to distinguish between these two? Because both of these have a 1 carbon branch that's a methyl. So what we're going to do is we are going to use a system where we label the carbons. And we're going to start numbering from that carbon on the end closest to our branch. Now I could start numbering here, 1, 2, 3, 4, 5, 6. And that would call this would be on the 5th carbon. However, I could also number it from here. So this is a hexane, and I have a methyl group on the 2nd branch. So this is going to be 2-methyl hexane. This one is going to be 3-methyl hexane. So again, I use these numbers to indicate where in this carbon chain the branch is attached to. And I'm going to use these locants, this number, quite a number of times. It will appear. So if you ever see a written number in an organic name, that tells you where something is attached. If you want to know how many carbons are there, look for the root that we see there. Okay. Now, I know you're not an expert at naming of organic compounds at this point, but I'm going to go through one example just for fun and go through everything to show you what can be done so we can move on to some additional things. Okay, so let's say I have this particular molecule, and hydrogen is all over the place. When I look at this one, in order to find the longest carbon chain, now I did it kind of nicely. I went ahead and put the longest chain in a row, although I could go from here to here or from here to here. These two and these two are interchangeable. But I'm going to start with this longest chain. Now, 1, 2, 3. 1, 2, 3. They're both 3 from the end. But since this one is a bigger branch, it's going to gain priority. I'm not going to go through how you tell what has priority over other things at this moment in time. Just be aware that when you're numbering from the end, certain things take precedence, okay? Now, in this particular case, I have a branch here, a branch here, and a branch here. I have two different branches. One branch has two carbons. This is an ethyl group. These two have there are two branches that have one carbon. There are two methyls. Now, if I use a number, that tells me where it's attached. So when I do this, there's a few rules. Now, this one isn't so hard and fast. I should put these alphabetically. This is ethyl. These are methyl. So I'm going to put the ethyl first. So this is going to be 3-ethyl. Okay. And here I have a methyl on 5 and a methyl on 6. Now I could say 5-methyl, 6-methyl, but I'm not going to do that. I'm going to do 5, 6 di methyl. Now I thought about doing 2 ethyl branches on here, but then that would be diethyl, and that sounds really kind of mean. So I figured I wouldn't do that. Okay, but it's 3-ethyl, 5,6 dimethyl, and if I count, I have octane. Again, I don't expect you to be experts at this. I expect you to recognize the system that's in place. There are some homework problems that you will see in chapter 23 and 24. I am not going to collect those. I do recommend that you spend a few minutes doing those. But again, it's not high priority for this class right now, but it will help you out when you start looking at some biology classes, okay, and some of the biochemistry that's involved. All right, so we have now covered alkanes, okay? Guess what? There are other types of bonds between these. It must be Monday. Coffee before I talk to you. Okay, there are other types of bonds besides single bonds. There are double bonds. And if I put a double bond here, a couple things happen. Okay? Now, first of all, I cannot have a 1-carbon chain that has a double bond. The shortest one I can have is this. First thing we notice, bond angles are different. This is an sp2 hybrid orbital. Okay, so it's going to change something. The second, if I have n carbons, I don't have 2n plus 2, so this is no longer a saturated hydrocarbon. So this is going to be C2H4. A saturated one would be C2H6. So this gives us an unsaturated. Okay. A couple other things that we notice about this. I can't name it as an alkane. Now, I had alkanes for all single bonds, and they get the suffix ane. These are known as alkenes, and they get the suffix ene. Ah, great. Let me see if I can make that a little bit more visible. Okay, it gives the suffix ene. So this one, I have 2 carbons, F, and I have a double bond, Fe. Now, in industry, this particular substance is known as ethylene. The system I am teaching you for naming is called the IUPAC system, International Union of Pure and Applied Chemistry, the same ones that give us the fun periodic table and have chosen things like element 118 is oganescent or Og. If anybody knows anything about the far side, Gary Larson just really wishes he would have that. Oh, somebody is asking if we're having a quiz this week. I'm going to take a side note and cover that. We do not have class on Friday. Friday is a study day known as Reading Day. It was going to be a study day known as Scholars Day, but for this semester, as we are an online format. They have decided to forego Scholars Day this semester, and it is reading day. It is a study day for you. So we do not have class. We do not have a quiz on Friday or anything. You are done with all quizzes and tests and everything except for the final exam next Monday, 10 o'clock through 12 o'clock a.m. Okay. All right. Chapter 25 is due Wednesday. Yes. Yes. It's due Wednesday. And I don't know if I put those up or not. I will have those up at the end of class today if they're not. I entered it in Canvas, but I don't remember whether I made it visible for you or not. And I'm only having you turn in 2 problems out of chapter 25. Okay. Okay, back to organic chemistry. Yep, I got plenty of time. Not really. If I wanted to cover organic chemistry, I need to start going into turbo mode. So I might go a little bit fast here, but this is recorded so you can go back and watch it. But again, remember, I'm introducing this to you, not completely teaching. Now, ethene, 2 carbons, F-E-N-E. What happens if we get to 3? That's going to be propene. But what happens if we get to 4? I have a couple possibilities. First possibility. First possibility that we see is that I have, now notice I only have 4 bonds to this. Okay, so I have 2 here already, so I only have 2 back. Okay. I can have my double bond between the first 2 carbons. So when I number this, now I number it in the end closest to the carbon double bond, the carbon-carbon double bond. So this would be 1, 2, 3, 4. Now notice this one I could number from either end. So in this one, it comes out really simple. This is going to be 1 butene. And this is 2 butene. But I have a problem. Remember, this is not a 180-degree angle. These are at 120-degree angles. So I have 1 butene. I'm going to erase the drawing of 1 butene because I want to show 2 possible 2 butenes. So if I have my double bond, notice that I have things off at angles. Now on this case, I have both of my carbons on the same side of the double bond. This is a cis isomer. So this is going to be cis to butene. And if I have it I probably should introduce you to this. This, if I write a CH3, this is another way that you will sometimes see methyl groups drawn because it has a C and 3 H's on there. This is what is called the condensed structural formula. This is a lot easier for people who do printing and everything to put a CH3 than to try to draw this out. So this is something that we see. This one is trans. Butene. So I have, in addition to the isomers where the double bond can be in a different place, which is a structural isomer, I also have geometric isomers, cis and trans, that have them. Now, notice I talked about these not being saturated, and now I have cis and trans. You've probably heard of trans fats, or you never hear of cis fats. Those are regular unsaturated things versus trans, which are across there. Now notice if I have a bunch of carbons in a row, the trans kind of keeps it in that zigzag pattern that we would normally expect to see from carbons versus the cis, which puts a bend in it. Because of that, cis things tend to have lower melting points than trans. The trans ones can be packed in together, and our van der Waals forces are much more strongly interacting in there versus we throw a cis in there and that keeps them a little bit farther apart, weakens the effect of the van der Waals forces. Okay. Yeah, I have to show this. Sisters. Transistors. Okay, go through a couple of jokes. Okay, we have alkanes, we have alkenes, just to keep us, there's all kinds of things that we're going to be able to deal with here. An alkyne is a YNE, and this is 2 carbons, F5. This is also has a common name of acetylene, and we'll see that. Now, triple bonds do not have geometric isomers. They don't have cis and trans because there's only one thing that can be bonded on each side of them. They are, however, linear and sp hybrid orbital carbons. So it gives them some different properties. I'm not going to go through all the naming of these, although if it has a triple bond, we're going to give it YN. Now, the 2 other things that we need to note about here. If I have, say, for example, 2 double bonds in here, how would I do that? Well, this would be a, I need to number it. I'm going to pick the right side just because I want you to realize that it could be interchangeable. So the first double bond is here. The second double bond is here. The first double bond is between 1 and 2, second between 3 and 4. I always give the double bond the number of the lowest carbon. So this would be butane, because 4 carbons is bute. But because I have a double bond, it would be butene. But because I have 2 double bonds, it's a diene. So this is 1,3-butadiene. And I know you're thinking, wow, I'm dying already. Okay. So a little bit more that we need to go through with hydrocarbons before we get into some other things. Okay. Hydrocarbons can be unsaturated in another way without having a double bond. Now notice, I have 4 bonds on each of these. They're all single bonds. This is an ANE. This is a 6 carbon one. So this is a hexane. However, because it's cyclic, it has a different property. This is called cyclohexane. Okay. Now I can combine things. I can combine a cyclic, and I can have something like this. So this would be cyclohexene, or I could go back to this particular structure, which has alternating single and double bonds. So I would call this 1,3,5 cyclohexatriene, or better yet, benzene. Now, I'm going to introduce you to another way of drawing chemical structures in organic chemistry. We're just going to draw lines. Now, if I draw lines, every place there's an end of a line or a corner. If there's an end of a line and nothing's there, that's a carbon. If there's an end of the line and there is another element there, like for example, I have something like this, that would be an oxygen, okay? We haven't gotten to those yet, so we'll come back to that. But this has 6 corners to it. This, as I've drawn, is cyclohexene, okay? To make it benzene, we can do that, or we can draw one of our resonance structures for benzene, although we probably should do that. I always call that the alien benzene. You might understand why. But this is the way I normally draw benzene because those pi electrons are delocalized and it gives us something. If it contains benzene, it's not the only one, but if it contains benzene, we have an aromatic. So in addition to cyclic, we also have aromatic. And these are all the types of hydrocarbons that we can have. So now we're going to move on to other things, okay? We're going to start adding other elements. Actually, we're just going to start with oxygen. And now you're thinking, oh, okay. But not okay, because that would be oxygen and potassium. Okay. So alkenes, alkenes, alkynes, we also have cyclic and aromatic. Now, I'm just going to scroll those up. We're still going to have those in our repertoire, but I don't have room for all of that. So imagine that I just scrolled up on that. All right, what if we have oxygen? Now, the simplest way that we can have oxygen, this is our simple methane. I can put an oxygen in between the carbon and the hydrogen, and I get an OH. And I know you're thinking, oh, that's pretty basic, and it's actually not basic, okay? Because this is a bond that we see, it is not an ionic bond, but a covalent bond. This is very much like the bond in water. And if we remember, if I have an oxygen bonded to a hydrogen, I have hydrogen bonding possible. So these can interact with water very well. This particular thing with the OH on there is called a functional group. It is a particular way that things are put together. And I get to introduce you to R. And no, this is not the pirates phrase, R, not that. Nor is it the ideal gas constant. R is a generic term for a bunch of carbons somehow. I could have one carbon, I could have a billion carbons, whatever. Some number of carbons with this attached to it is what this means. So if I have R with an OH, this is known as an alcohol, and we give it the ending OL. This particular one has one carbon. So we would normally name it methane, but we're going to drop the E. I drop the E and add OL. That's methanol. We've used methanol in the lab. It does a pretty good job of pulling off Sharpie, among other things. It is soluble in water, and that's one of the things that's going to be important. Alcohols are very soluble. Now, notice that this, even though it's an OH, is not a basic thing. So one of the things they like to do on standardized tests and everything, or talk about which is going to be the most acidic or basic, and they'll throw an alcohol in there just to make sure you know what you're doing. If you see an OH attached to a carbon, that's an alcohol, not a base. All right, let's continue on. Let's make them a little bit bigger. So that's methanol. Here's one. This one is known as ethanol. Ethanol has a number of uses. We find it in our gasoline quite extensively. There are actually entire stores made to sell products containing ethanol. This is what we know as ethyl alcohol, or when people drink alcohol, this is what it is, okay? And it has properties that are similar to water. One of the reasons that it affects things is that as it gets in your bloodstream, it acts like water. It just does things a little bit differently. I'm not going to go into all the things that it does. Now, methanol is actually poisonous. Methanol will kill you if you get too much. Actually, ethanol can do that too, but you have to drink a lot of ethanol to do that. Don't test it. Don't see how much you can drink before you die. The problem is that the only way you can possibly test that is to die, and I don't want you to do that. I actually have known a couple people who died from alcohol poisoning, not close friends or anything, but I did know them. They drank too much. Okay, it can be done. Don't do it. Okay. I'm not going to tell you that ethanol is evil because it's not. There's a lot of good uses for it. And I have been known to drink a little bit of it here and there, but definitely do not drink too much of this. It will do a lot of damage. You can learn more about that in some of your biology classes. All right. So ethanol is fairly important. Now, there is a common name for this. This is methanol, ethanol, but this is also, the old name is methyl alcohol, ethyl alcohol. There's another common type of alcohol that we're going to look at. Now, if I get into 3-carbon alcohols, that's going to be propanol. And I actually have 2 types of propanol. I have 1 propanol and 2 propanol. Okay. This particular one is called isopropanol. Or isopropyl alcohol, or 2-propanol. 2-propanol is its IUPAC name. 1-propanol is this IUPAC name. This is also sometimes called N-propanol. So that goes through alcohols. Alcohols are really important. They tend to make things fairly soluble in water. Okay, now if you get really long chains of alcohols, they may not be as soluble in water, but we see that. Now, there's other ways that I can attach an oxygen. Okay. I can put a carbon double bonded to an oxygen. Okay. And that carbon double bonded to an oxygen generically is known as a carbonyl. And there are a number of different functional groups that contain the carbonyl. The first one we're going to look at is one that's on the end of the carbon chain. Okay. And let's start with let's go with a 4-carbon. This particular thing is known as an aldehyde. And I know you're thinking, an aldehyde, what's that? Well, it's when I do this. You can't see me now, right? Oh, that's not what we mean when we want aldehyde, okay? You can call me Al, Alan. All right, that's somewhat funny. IUPAC-wise, we're going to give it the ending AL. So this would be normally butane, but I'm going to drop the E. There are lots of E's down there now. And I put AL. Now make sure you have good handwriting and make sure you have a good quality camera. So maybe you can see it a little bit easier. It's real easy if you're not paying attention to confuse butanal and butanol. They're significantly different. Now, one thing about this is always on the terminal carbon. It's always on the end, so I don't need to number an aldehyde. Okay, I would need to number an alcohol. So that's another way you can keep those straight. Now, there's a couple other things that we need to see. Okay. So this is an aldehyde, and it's an aldehyde that contains 1 carbon. So I would call this methanal. However, it has a common name. In the old system, if I have 1 carbon, it gets the prefix form. So this is a 1-carbon aldehyde. So this is formaldehyde. Now, if you're going to buy it, you would buy formaldehyde, not methanal. Even though if you went to a place that knew anything about chemistry and asked for methanal, they would give you formaldehyde. Okay. If I have 2 carbons on it, it gives the prefix ACET. So this is acetaldehyde, or ethanol. Okay. So this is a carbonyl at the end of a carbon chain. If I have a carbonyl in the middle of a carbon chain, it's going to give me a different set of properties. Now, notice that in an aldehyde, I have this hydrogen here along with this oxygen that gives it some unique properties. If I have a carbon double bonded to an oxygen in the middle of a carbon chain, there's no hydrogens on this carbon or anything, it's going to give it some different properties. This particular one is a ketone. And I have lots of ketone jokes, but I don't have much time, so I'm going to skip those for now. Okay. A ketone is a carbonyl in the middle of a carbon chain. And if I have a ketone, it's going to be polar, so it's going to be usually probably a liquid at room temperature. If I get really long chains, it'll be solid. But it'll be liquid at room temperature, but it doesn't have quite as strong a bonding as something that has hydrogen bonding present. Now, this particular one is named a little different. In the old system, they say, there's our ketone, and I have 2 carbons to it. So this is acetone. However, its IUPAC name would be propanone. Now, if I had butanone, there's only one way I can have butanone, because either way, I can put it on this one or this one, it's still going to be 2-butanone. But once I get to 5 carbons, I have to put the number where the ketone is. And I'm not going to go too much time on that. So that's a ketone, okay? I can also have the oxygen in the middle of a carbon chain. And in this case, I have an ether. By the way, ketones get the NO and E. I'm not going to go into the naming of an ether, although I will name this one. This is ethyl, and this is ethyl. So one of the things that we could do is call it ethyl-ethyl ether, or diethyl ether, but that's not very nice to ethyl. Okay, make sure I don't run out of time. So that's an ether. There's a couple more things that are important. I can also have a carbonyl with an OH and put these together. Now this is known as an organic acid, or a carboxylic acid. And we give it the suffix oic acid. So in this particular case, this would be methanoic acid. Although, remember the old system, 1 carbon, formic acid. What if I have a 2-carbon acid? Okay. Now, this one, 1, 2, ethane. Ethane, drop the E, add oic acid, ethanoic acid. According to the IUPAC naming system, that's what it is. Although if you go to get it anywhere, 2 carbons, ACET, that's acetic acid, okay? Now, if I combine an alcohol and an acid, so I have that's an organic acid or an oic acid. Not going through the naming of the others, but there's a few others that we need to look at just to know that they exist. In addition to an ether, I also have I can have a carbonyl with this. And this can happen when we react an alcohol with an acid. They'll actually pull water out of it. It's called a condensation reaction. And this is going to give me this um, particular substance. This is known as an ester. Okay, and there are some where you can have an ester, a repeated ester bond known as a polyester. We won't go into that too much. This is important. And then if I change this to an N, that's an amide. Okay. Show you two more things. This one won't be very nice. I know, it's a mean one. And if we have an NH2 on something, this is known as a primary amine. Now the nitrogen can actually be bonded to more than one thing. So I can have C and C with an H. This would be a secondary amine. Or I could have N bonded to 3, that would be a tertiary amine. So we have amines, we have amides, we have a lot of things. The other thing that we could do is going back to our hydrocarbons, I could substitute a halogen for any hydrogen. And I just name it kind of like a branch. So this would be propane, and this would be chloropropane, very specifically 2-chloropropane. Or I could stick a fluorine on it, and I could have fluoropropane. And if I put both chlorine and fluorine on them, I get a chlorofluorocarbon. And I think that's a good enough introduction to organic chemistry. No, I did not teach you organic chemistry. I introduced organic chemistry and all the functional groups to you. I will talk a little bit on Wednesday about the importance of those functional groups to biological molecules. And with that, I am going to go ahead and end class right now. I will have office hours again at 11 to 11:45 and from 1:30 to 2:15. Have a good week, everyone.